Good day, everyone, and welcome. Thank you for your time and this opportunity. I'm looking forward to showing you the many different benefits that Civil Designer has to offer. I'm going to start off with some visualization capabilities. Everything you're about to see is done inside Civil Designer with its common interface and full integration between roads, foul water, surface drainage, potable water, and even auxiliary services. You can travel beneath the ground and check for clashes between these different services. And then start off with that and then go beneath the ground. And as we approach these pipes, I'm going to slow things down somewhat. If you look at the position of my cursor, eventually you'll find that we've got a yellow balloon. That yellow balloon indicates that we've got clashes between our different services. Not only if they clash, but also if they're within a certain proximity, will Civil Designer point it out for us. You can view this drive-through from any perspective. Looking in front of us again, you'll see there's quite a bit of color. This is what we refer to as the water film thickness functionality, where Civil Designer calculates the probability of aquaplaning. I'm going to lock my view, and instead of driving down the road, I'm going to use the fly along a road using a drone approach. While you are busy presenting to your potential clients, there are different preset environmental settings to choose from. Depending on what looks good in your presentations, you could go and select the most appropriate option available to you. You aren't limited to driving along just one road. You can press Escape on your keyboard and select to drive along a different road. We also give you options of viewports. Depending on what you've done in your designs, you can go and save these viewports and then use it for verification or presentation type purposes. If you'd like to view, for instance, this interchange from a 360-degree perspective, you can go and right-click and select Circle Around. Everything you're seeing here is done inside Civil Designer's CAD module. Looking at the Drawing tab, this is where you do all your designs, and next to that we've got the layout. These layouts will dynamically update as you make changes to your designs. You can go and customize how you'd like these layouts presented, and if I want to go and publish this, I can go to Plot and select Publish Layout. Specify which layouts I want to publish, whether I want it as a coordinated drawing. I can also export the plan lists as CSV files. That would be this table in this case. I can publish to PDF, and then we always give you the BIM naming standard files to choose from. And then specify where you'd like to go and save it, as well as if you'd like to save it in a DWG or DXF format. If from the onset you'd like to save your project as a DWG, you can do so. This is done by going to File, Save As, and then again saving it as a DWG format of choice. We also give you numerous import and export facilities, making provision for our civil industry's interoperability requirements. You can export to KML as well as an IFC, Industry Foundation class file. Looking at the different options, you don't have to export the entire project. You can do individual modules. Again, you don't have to do all the roads. You could deselect all of them and just select the roads of choice. Further down the list, because of Civil Designer's integration, you can also export the foul water, surface drainage, potable water, and we've made provision for auxiliary services. That would be your electricity, fiber, and gas lines, as an example. Further down the list, you can export your road layerworks. You don't have to do the entire road. You could segment them in different lengths. We've got a signage module, so you can export the road signs, markings, and road furniture. As mentioned before, we got the BIM naming standard files to go and choose from. We present you with different schemas or formats. As the industry increases the options, so do we develop those options inside Civil Designer. Different catalogs, and then by default, all the IFC properties are switched on. It's easy for you to disable them and then right-click and insert your own customized IFC properties. That in a nutshell is what I'm about to show you, looking at Civil Designer's different applications, allowing its integration and common interface increase your team's productivity. I take it that you work with bitmaps or aerial photographs quite often. Not only do we handle 3D images, but we also handle very large bitmaps. I'm going to show you an example where I bring in a 28 gig bitmap. Just to give you an idea, this particular drawing that we have in front of us is close to 41 megabytes. And then you insert the image by going to Insert and selecting Image. Specify the image to bring in, and we're looking at close to 28 gigs. We got confirmation that the image has been placed in the correct georeference position. To zoom out and show you the extent of this image, you have the option of saving viewports. Depending on the design areas of choice, you can go and save these viewports. And as an example, if you don't do a development where the sports ground is, you don't particularly want to be working with a large 28 gig image all the time. So instead, you can go and right-click, Save Cropped Image, specify the region of the image that you want, specify where you'd like to save it, and I'm then bring that image in. So I go to Insert, I select Image, select the one that I've just created, looking at close to 6.5 megabytes. To zoom in, you can see this image is georeferenced. So instead of working on the large image, I can now go and delete it and then focus in on my design area of choice. Alternatively, if you don't have an image, I've got the solution for you. Within Civil Designer, you can go to Insert, select Bing Maps Aerial Image, specify your projection settings, and I'll go into a lot more detail as far as that's concerned shortly. Within a couple of seconds, you'll have an image. You could then go and specify where you'd like to save this image. Civil Designer presents us with the generous amount of image that can be utilized for your design purposes. Deleting the image. One of the most frequent asked questions within these demonstrations is how do you go about creating a project inside Civil Designer and importing your surveyed information? I'm going to show you that next. We go to our survey mode, go to File, Project Settings, and we're going to create a terrain file. Specify where you'd like to save this information. At this stage, you could activate the different modules. For now, I'll just bring in the survey. You aren't limited to a particular hemisphere. As far as the rest of the projection settings are concerned, we made it easy for you by giving these preset options. You could go and specify where in the world your project is situated. Alternatively, you could go and type in a country, and Civil Designer will give you the different options associated to that country. This particular project that we're looking at the moment is done inside South Africa. I've set up the projection settings accordingly, and I click on OK. Now that we know where in the world the project is situated, I can import surveyed information. And there's different ways that you can do so. If I go to Import, if you've got a 3D drawing, you can convert those drawing entities into your DTM or digital terrain model. We make provision for TIFF, DEMs, LiDAR surveys, Land XML, but in this case, I'm then bringing an ASCII file. If you don't have a survey and you need to bring in a grid for preliminary project purposes, you can use the Bing map functionality found in the terrain mode. It is a comma delimited. I'm going to click on next. Specify the headers for the columns, and then you have the option to go and save those settings as defaults. Within Civil Designer, you have the option of using 255 different surfaces. Those are the grid surveyed points that we've just imported. Next up, you probably want to generate your contour. So we go to the terrain mode, go to model on top, select triangulate. It will then join all the surveyed grid points with lines, and from that you are able to go and activate your contour display settings. It's very easy to go and customize these display settings. This is what we refer to as dynamic contours. With dynamic contours, you are able to make changes to your contours. Once you're happy with them, you can make them permanent contours by going to Terrain, Generate Contours, specify your customized interval, and then go back to your display settings and update the defaults. Again, very easy to customize the display settings. If I were to zoom in, the contours are now labeled. If you'd like to put in your own contour interval and you got the surveying terrain module, you can go to contour labels, add label line, specify your surface, and then click where you'd like these labels to be. That covers the Design Center module. Moving on to the Surveying Terrain module. With the Surveying Terrain module, you'd want to go and do platform designs, terrace volumes with cut and fill. I'm going to show you more of this. Before we do so, I'm going to take full advantage of the render view to show you what the site looks like. Civil Designer also gives you the option of using some preset terrain settings. To show you an example, if you want animated contours, you can increase or decrease the contour density, which will assist with determining your catchment areas. Reverting back to what we had before, and then exiting the render view. Now that we know what site looks like, I'm going to go and turn off the bitmap or aerial photograph, turn on the cadastral. And when we do our platform designs, I want to be able to see beneath the ground, so I'm going to turn on the shade transparency. Zooming into the design area of choice. Looking at platform or terrace designs, there's different ways that you can do it. For demonstration purposes, I'm going to show you how the strings functionality works. I'm going to start off by going to strings, string creation, define string graphically. There's different options available to you to define the heights for the bend points. In this case, I'm familiar with the site elevation, so I'm going to put that all in at one elevation. And then click along the intended route. Because of its user-friendly functionality, it's very easy to draw this in, very much like you would drawing CAD lines. I do have the option to right-click and close. Alternatively, I can leave it open, and at a later stage, I could go and select it and then change the properties of that string. I can move the string as a family, or I could move individual vertices. This is what we refer to as a parent or master string. From the parent, you generate the child, and the idea behind that is if you do go and make changes to the parent, the child would dynamically update. Now go and put in the embankments using the child string. So we go back to strings, string creation. I do have the option to apply a curb if I'm doing a parking lot design. Let's do this before we put in the child. So we go to apply curb, put in a full range on the outside of the master string. Civil Designer comes with a library of curbs to choose from. You would select load group, specify which curb you'd like to use. We've got the Vanstone, the SABS, the British standards. You can also customize your own curbs. Now that we've got the curb, let's go back to putting in the embankment. We go to strings, string creation, create child, select in full range. When we create this child, you can go and customize the name, operation types, and there's many to choose from. In this case, I'm going to go and grade it to the ground level. Specify cut and fill slope, and they can be different. Those additional lines that we see, those are the dynamic contours that have already been drawn for us, and the selected line is the toe line. If I take the parent and I move it, the child would dynamically update. Next up in your design process, you probably want to give the parent string a bit of grade to make provision for stormwater drainage. You could right-click, select string operations, string long section, and make changes to your design using the toolbars on the left. You could, for instance, take a vertex and move it up and down, and then ask Civil Designer to interpolate elevations in between two vertices. In this case, I'm going to do the change via the plan view. So I go to strings, range editing, vertical grade. Specify a start point and an end point. Specify which side I'd like to edit. And I choose a negative 2% grade. The contours are dynamically updated. If I want to edit the other side as well, go back to strings, range editing, vertical taper, specify a start point again, end point, select the other side. For verification purposes, again, you could right-click and select render view and go and view this from a different perspective. You can see what is in fill, and then looking beneath the ground, you'd be able to see what is in cut. If I do zoom into the parent string, you get a better idea of the curb that we inserted. With cut and fill volumes, you go to strings, string editing, and you select volume. Specify the parent string. If you do have additional surface information that would include extra over, let's say for your hard and intermediate material, then you could go and include those in your volumes straight away. You'd simply go and specify which surface to use. And that would be included in the cut and fill volume. Straight away, you could go and specify the topsoil to strip and compaction factor. And for reference purposes, you could go and customize your description for your volume calculation. This is reference to a report volume that I'll show you. Specify where you want to see the results. The screen output would be here on the right-hand side. if you want to send the results to a printer or create a text file of it, or the option of all three. Looking at the output bar, we've got the volumes, which also then includes your curb quantities. In an ideal situation, you want your cut and fill volumes to be optimized. In that case, you go back to strings, string editing, select balance cut and fill volume, and then switch off the extra over option. And I'm opting here for 5% optimization difference between my cut and fill. If I want to update the description, it will take the parent string, it will alter the elevation, calculate the cut and fill volumes until it's within the 5%. If I now go to terrain and I select report quantities, there's the previously mentioned curb quantities, and then looking at the two calculations that we did, one where we didn't specify the optimization, and then the second one, or the phase 2, with the optimization turned on. Still staying with strings, I'm then putting a new string on top of this existing string. Before doing so, I'm going to update my display settings. I'm going to turn on the banks. And I'm going to turn on a CAD layer that I'll convert into a string. Changing my pen colors so we can distinguish the difference in the rendering. This is a lightweight polyline that I've gone and selected. We then convert that into the string, so we go to string creation, string from polyline, select polyline. You do have the option to specify the heights from the polyline. In that case, with the 4 different vertices, they would pick up the elevations from those vertices. In this case, I'm going to do things a bit differently. I'm going to ask Civil Designer to go and add a constant of 10 meters to not only the ground surface, but also the existing string that we've already created. Earlier on, I mentioned you can create embankments for partial segments of the string. I'm going to select the new string. I'll go back to string, string creation, create child, partial range. Specify on which side of the new master you want these embankments to be. Select a start point and an end point. I'm happy with the range. Customize the default settings. I'm going to include the existing string when we grade this. Pressing escape and then hitting spacebar to bring up the previous function. Select the master, select which side I want, the start point and the end point. Let's take a look at this in 3D. Right click, render view, and then zooming in and viewing it from different perspectives. If you're looking at dam volume design, I'm going to show you another example using the survey and terrain functionality. Now open up a different project. To give you an idea of what the site looks like, again, I'm going to render the view. And then using the toolbar here on the right-hand side, we get a better idea as to what our site looks like. We've gone and put in this dam wall, and the idea is to calculate the dam volume behind this wall, and then also look at our flood levels. Looking at the dam volume, we go to terrain, scroll down to dam volume, specify the water level and which surfaces you're working with. If you choose to select a reservoir file, you could use it inside the stormwater module to simulate retention or retention ponds. Reading my prompt, I click inside the dam, specify where you want the result, and looking at the cumulative volume in that case, close to 226,000 cubes. You have the option to export this as a CSV file. And looking at the graph, you could go and specify what needs to be shown. Civil Designer has left a polyline indicating the water level that we specified. Using the strings functionality that I've just shown you, we're going to convert that polyline into the strings so we could view it in a 3D format. And then pick up the elevations from that polyline and then rendering it. Not only have we calculated the dam volumes, but we can see it in the 3D format. Looking at flood levels, I'm going to delete the dam for presentation purposes. I'm going to go to terrain, drainage, and this time select flood levels. Specifying the flood level. I'm then going to put in a solid fill at the flood level only. Don't forget that you have the option of putting in a description for later reference. And then looking at the updated cumulative volume. Again, if you want to see that in 3D, you could go and render the view. Another function that I'd like to show you before we leave the surveying terrain module is looking at surface maximum. Once I go and select this icon, the flood level will change. It will use the highest elevation within our site and then calculate the volume from the highest elevation, which would essentially be a fill volume. It may be for borrow pits that you'd like to use this functionality. Again, you could go and specify which CAD output you'd like to use and make things interesting. I'm then going to put in a polyline at every depth increment. Looking at the new cumulative volume. If you go and render that now, perhaps easier to understand what the function does when I show it to you in the 3D rendering. Taking the highest point, projecting that along the perimeter of your site, and then calculating the volume. That's the surveying terrain module. Moving on to the next modules. Moving on to the roads and pipe services. Please don't feel like you need to create different projects for the different modules. That's certainly not the case within Civil Designer. To show you this, I'm going to open a project that has an integration of all the different modules. Before we get started with the designs, I'm going to take full advantage of Civil Designer's rendering and show you what our site looks like in a 3D format. Looking at the defined viewports, you also have the option to define your own fly-through paths, where you can view beneath the ground as well as view it from any perspective possible. Civil Designer gives you the option to enable a video capture that you could then pass on to your potential client. We don't focus in on the road design. I'm going to go to my display settings. I'm going to turn off the potable water, surface drainage, foul water. I don't need to export to any other software program. I simply go and select the roads mode. The menus will change. And before we do the design, I'm going to show you that if we go to the option settings, you can design up to 2,500 roads within a single civil designer project. Some of our clients have designed up to 400 kilometers on a single road without the use of XREFs. I'm opting to use the interactive road expert. That road expert would guide me through the design process in a similar manner. If I'm done with the design and I need to revert back to any stage of my design, Civil Designer will then recalculate the road for me. There's different ways that you can do your road design. In this example, I'm going to utilize this red dash CAD line and pick up the horizontal alignment. Alternatively, if you don't have CAD entities representing your alignment, you can go to alignment horizontal and then manually graphically insert your PI points. Before we do the design, I'm going to go to File, select Road File. This information dialog appears. These are all the roads within our project, giving us information when they were last modeled, if you use the design criteria, what speed that would be, and then looking at the surfaces and the different layers. This will assist you in keeping your standards uniform. I've created a road here called Demo Road, which is incomplete. Looking at the control panel, you can give it a specific customized name, specify which generation design method you'd like to use, specify your template, and this is what the road would look like in cross-section. I'll go into more detail as far as templates is concerned at a later stage. It picks up the template dimensions and populates the information here below. You can choose to use a certain design criteria from the start of the design or utilize it at a later stage. Looking at the layers, we give you 128 different cross-sectional layers to use within a single road. And that would be things like your surfacing, your base, your sub-base, your subgrade. It's easy to customize the display settings and then save it so that should you use it at a later stage, you can go and load it. As with the surveying terrain module, if you want to include extra over excavation volumes, that could all be done at the same time. You would go and activate them here and specify your surfaces to use. Looking at what the current horizontal alignment looks like, everything is blank. We don't pick up the horizontal alignment using the regression functionality. I do so by going to Alignment, Regression, Extract Alignments. It's very easy to swap between a dual or single carriageway. You can pick up all the design elements using this functionality. I want to show you as much design features as possible, so I'm just going to pick up the horizontal alignment. But should you choose to, you can also pick up the vertical alignment, as well as the super elevation, and pick up road edges from CAD. Civil Designer will ask me to extract the horizontal alignment from. I'm going to select CAD entities, select that red dash line I pointed out earlier, and then for confirmation, I'm going to click on yes. To revert back to that horizontal spreadsheet I showed you before, it is now populated. Even though it is populated, I can still go and make changes to my design. All of these values are customizable. Alternatively, if I go to alignment, horizontal, I do have the option to go and edit the PI points as well as insert my own, delete existing ones, and move them. Closing the spreadsheet and then asking Civil Designer's Road Expert to do the rest of the design for me. During this process, it will automatically go and insert junctions or the intersections for us. gone through the entire design process, and straight away I can go and view this in cross-section. So I go to section, graphical edit. I can go and view what it looks like in cross sections. As I press page down on my keyboard, the position of the cross section will update in plan. Take note that the crossing services are also immediately available to us. If you're thinking we've got too much cut, I agree with you. Let's go and make changes to the vertical alignment. I'm going to close this. At any stage in the design, you can go to alignment, select design criteria, specify that you'd like to use the design criteria. At the bottom, we have options of ASHTO, CD109, or TRH. And then you could go and specify which design speed to use. This will be applicable to all the design elements of choice. If we do now go back to the vertical alignment and we make changes so we don't have the cut, it will then populate the vertical alignment information with the design criteria that we specified. If I right click, there's an option of Insert PI. I can go and press G on my keyboard, enter. As mentioned, the curve length has been inserted according to the design criteria. Once inserted, I can still right click and I can select Move PI and then move that position up and down, left and right. Alternatively, if I'd like to be precise, I can go and select the spreadsheet and go and round my values off. Happy with that, I can go and close it and save it. Civil Designer will recalculate our road using the new vertical alignment information. At this stage, you may want to go and plot your road. Again, in Civil Designer, we've made it easy for you. If you go to Plot, select Generate, specify which customizable sheet file you'd like to use. Looking at the road long sectional setup, we include the option to display crossing pipes. That would be your other services if you'd like to see them on the finished plot. Specify the cross-sectional setup with your own offsets and intervals. If you've got a very long stretch of road, you could ask Civil Designer to automatically pick up the center line of your road and plot along that stretch of road. As we've got a shorter road in this case, and then you redefine all. Moving my cursor to my plot center, and then having the option to rotate my plot. Right click, quit. I'm selecting that I want PI and curve list information. On the top, we've got the plan view, and it's very easy to move these lists. No need to create viewports or mask the background. On the left-hand side, we've got the cut and fill areas. And then looking at the long section, you can go and customize how you'd like this all displayed with your company's title block. These layouts will dynamically update as you make changes to your plot. Reverting back to our design, when we created the road, I mentioned we used templates. We're going to go into more detail as far as templates is concerned. Going to Tools, Template Paths, taking a look at the template that we're currently using for this road. It's very easy to swap between a single or a dual carriageway. Within Civil Designer, you have the option of using 4 different grades if you choose a dual crowned template. Looking at our curbs on our roads, we've got a whole library of curbs that are built into Civil Designer by default. If I select Load Group, we've got the British Standard SABS Vanstone. You can take an existing curb and you can edit the curb and put in your own dimensions, save it, and then utilize it at a later stage. Civil Designer will also calculate the quantities of the curbs for you. Moving on to the pavement layers. Built in by default, if you right click, there's a TRH4 pavement option where you could go and specify your pavement type, climatic region, road category, traffic class, and if you're not quite sure of the class, Civil Designer can calculate it for you. Having selected your traffic class, the different options available will be presented. You then go and select the most appropriate option. Alternatively, if you don't want to use the TRH4 pavements, there is an option of Pavement Designer where you can add layers, edit layers, delete layers, and then save it. On the left-hand side is what we refer to as components. You can go and create your own components. You can edit existing components. You can take a drawing and convert it into components. It would include things like guardrails, V-drains, trapezoid drains. If you're looking at using a particular component, you can left click, hold it in, and then move it to the position of your red arrow. Letting go of my mouse, it's that easy to position it. Alternatively, if you want to delete that component, you do so by clicking on it. If you're looking for something with a little more detail, I'm going to load another template. This template would be a dual carriageway example, where you got median information and you can go and customize the median. You got sidewalks, you got barriers, pivot points, additional sidewalks, V-drains, and then you could go and specify different cut and fill perimeters. Depending on the amount of cut, it may be that you want to include gabions until eventually the cut is great enough that you'd replace the gabions with retaining walls. You could also go and right click and select add ground and put in your own ground conditions to test the different cut and fill perimeters. Pressing escape, the retaining wall's height is dynamically updated according to the amount of cut and fill. Returning back to our road design, it's very easy for you to put in junctions or intersections within Civil Designer's road mode. To show you an example of this, we go to Junctions, Add Junction, click on the intersecting road, click on the main road. This user-friendly dialog box will appear where you can go and customize things like your coordination interval and which templates to use. Take note that I didn't have to remove curbs on the main road beforehand. Selecting the left curve, we're presented with a dynamic preview here. If I do go and change, let's say, my center radius, the preview would then be updated, giving me a good indication as to what the final product would look like without me actually clicking on OK. Reverting back to what it was, you can go and change lead in with curve and taper as well as lead out curve taper values. The edge conditions with your bow mouth can be changed from linear S-curve, and if you've got a CAD drawing representing the correct elevations, you could utilize that too. As before, you have the option to apply curves. If you want divider islands on the left-hand side, you could incorporate that. Same thing applies to the right curve. Looking at the center island, if you've got this from CAD, you could pick it up from your CAD entities. This is also applicable to the left and the right curve. Alternatively, you could go and specify your own dimensions using this legend on the right-hand side. Once you've specified your information, you can go and save it and then load it at a later stage. Specify where you want the results so you don't have to do additional work to get this information. It is already available to us. The setting out information is presented in the output bar. And then looking at our design, it's been updated accordingly. We also give you what I like to refer to as verification display tools. As an example, I'm going to go and select contours. Switch on the contour display for the entire surface of our roads, not just the edges, and then specify my slope arrows. In addition to this, I can also ask Civil Designer to customize the road shading. If I select Drainage Display, Civil Designer will highlight if you've got flat slopes, which may be a problem for your stormwater ponding. You can go and highlight high points with the elevation and customize these symbols. Same applies to low points. If, for instance, you'd like to put in a curb inlet symbol for your low points, you can do so. The display is updated. Having done this, if you need to go and make changes to your junction, you simply go back to Junctions, Edit Junction, click on the junction. This dialog, as we had it before, comes up again, where again you could go and make changes. If you'd like to alter your bow mouth vertical alignment, you can go back to Junctions, Bow Mouth Editor, select the bow mouth. As you move your cursor in the long section, you'll see there's a big red cross in plan, giving us a good indication as to where we are positioned. I'm going to over-exaggerate the changes made here just to emphasize the functionality. I'm going to say move this vertex to a different elevation, then interpolate the elevations between the start vertex and the end vertex. Same thing applies to the other side. And then ask Civil Designer to insert a vertical curve between a start point, an end point, and a through point. Closing that, no need to save it. Switching off those additional verification tools. When I inserted this junction, I was going through quite a bit of detail explaining what was needed. So in real time, you go to Junctions, Add Junction, select your intersecting road, your main road, click on OK. I'm going to turn off the screen output for now, and the junction will be updated. Another reason why I inserted that junction is because I want to take this road, I want to make changes to the left edge, I want to make it wider so I can show you how Civil Designer updates the junction. And then go to a CAD layer representing the new left road edge width. There it is. And then going to alignment, regression. This time I'm then going to select the extract strings. I'm going to pick up the CAD entities. I'm going to alter the left edge of our road. When I do so, I choose to retain the existing crossfall. Select the CAD dash line, right click. Civil Designer will then recalculate the road using our new width. As can be seen, the junction is updated. If we go to Section Graphical Edit and we view the new width of our road, there's the additional width. And then pressing page down, you'll see how the width reverts back. What it was, it's utilizing the previously specified grade. If we revert back to our layout, the layout will then have been dynamically updated. The layout is now dynamically updated with the two additional junctions or intersections and the additional width on the left. We also handle cul-de-sac designs with ease. Show you options available. I'm going to go to Junctions, Edit Junction, click on one of them, and then using my mouse wheel, we could browse through different types available to us. If, for instance, I choose to use this hammerhead, but I'm not quite convinced I've got the right dimensions there, I can then go and update the dimensions, see the dynamic update, and once I'm happy with the dimensions, click on OK. specify if I want the setting out information, and then click on OK. We also handle mini roundabouts with ease. If I go to junctions and I select Edit Junction, click on the mini roundabout, we can go and specify which crossfall to use, or if you want to drape the crossfall on the main road. Specify again the curb that you'd like to use. If you feel that the center island is too small, I tend to agree with you, so I'm going to increase that to double the radius. The mini roundabout will be recalculated with the new specified dimensions. Looking at the signage module. With the signage module, Civil Designer will dynamically update some of the markings and the signage. If you make changes to your road design, it will also calculate the quantities. To show you this, I'm going to road signs, add road sign, specify which library you'd like to use, browsing through the many different options. You aren't limited for choice. If you'd like to filter it out, you can do so. The preview will be updated where you could go and specify the size, material, height, things like the number of supports. And the reason why we give you so many options is because Civil Designer will calculate the quantities for these road signs. Looking at the foundation option, if I go and change that from rectangular to continuous, it would then be updated. Reverting to a stop sign, I'm going to go and turn off the filter, select a stop sign board and the size. I can go and click where I want the signboard to be and then specify in which direction it should face. While we are busy inserting these road signs and these road markings, we're working in a user-friendly 2D environment. Behind the scenes, Civil Designer is creating a 3D model for us, which I'll show you once we're done. Moving on to road markings, traverse markings. Let's put in a skew pedestrian crossing. You can go and customize these dimensions. Click on the start point. And then as you go and move your cursor, the marking would then update. Looking at linear markings, I'm going to purposely put in the incorrect dimensions and then show you how easy it is to update these dimensions via the properties bar. If I right click and select paint settings, Civil Designer will calculate the quantities for your paint and your retro-reflective beads. We've got existing paint types and you can go and add, delete and rename them. Selecting the linear marking, looking at the properties, I want to update the start of this marking. I go to Start Change, press Enter, and the marking start position has been updated. In a similar manner, I want to change the offset. I also have the option of customizing linear road furniture, where you can create your own furniture from CAD drawings and then insert them into your road design. Taking a look at what we've created in 2D, Civil Design has created the 3D model for us, which makes it not only good for verification, but also for your presentations. To end the roads mode off with, I can go to area volume, ask Civil Designer to calculate the mass or volume, cumulative volume, layer work volumes, curb quantities, component quantities with their layer works, and that would be things like your V drains, your sidewalks, etc. The road signs, the road markings. Report quantities is a report with all the roads present in the project. They are subdivided into areas, layer works, components, curbs, markings, and signs. You can right click and write all to file, where you have the option of creating a CSV and an XLS file. Further down the list here, we've got default combined. Those are all the roads with their junctions. You also have the option of customizing your own report, where you can go and specify a report type. You can go and customize the roads required for this report. Those roads would now be presented. At a later stage, should you wish to do so, you can right-click, edit report, and change the report type to, let's say, layerworks. That concludes the road section of the demonstration. If you prefer to see how highways are designed, please watch the highway design demonstration. Moving on to the next module, I'm going to turn off the display for the roads. I'm then going to activate the stormwater module. While I'm turning things on and off, I'm going to go to my XREF manager and switch off all my XREFs. Zooming into the network, you can go and customize how you want all of your modules displayed. As an example here, if we go to nodes, you could go and customize the symbols and use your mouse wheel to browse through the different options. You could go and specify your own specific pen colors, line styles, and scales. If you want additional information associated to the node, you could right-click and select the options. And this is applicable to your links, your subcatchments, and the option to specify color scheme. How did we get to this stage? You may be asking. There's numerous options available to you. You could, for instance, go and select the stormwater module without having to export or import from or to different software programs. And you could go to graphical and manually add the network in. What we're going to do for demonstration purposes is take a CAD drawing and then convert it into our network. So first of all, I'm going to go to my project settings and then get rid of the existing stormwater file that I've got. I'm going to use a clear example. I'm going to take CAD layers and then convert it into my network. So I'm going to turn on those CAD layers. The storm link would be straight lines. Nodes, if you've got manhole names or node names and you want to utilize them, you could save it onto a specific layer. And then looking at the outfall, it would be presented by a bigger circle. And you aren't limited to just one outfall. You could have numerous outfalls within the network. Before we do the conversion from the CAD layer into our network, you could go to edit and set up these settings and parameters. Looking at them, I'm then go to default settings, where you could go and specify manhole types, and you can go and customize these manhole types. Looking at manhole conditions, peril type, where again you could go and customize your own material type. Looking at the diameters, if you prefer Civil Designer to auto size the link diameters for you, you can choose auto sizing, and it will take your runoff information and size your links accordingly. Alternatively, if you're analyzing an existing network, you can go and choose the diameter of choice. The SABS bedding classes are built into the program, but you can go and customize them. Looking at the layout option, if you do choose to use that graphical functionality I pointed out earlier, Civil Designer has the option of automatically inserting manholes where the link length exceeds 80 meters. Moving on to design parameters, there's numerous inflow calculation methods to choose from. You can specify Colebrook White or Manning friction loss formula. Further down the list, you can go and specify the flow controls with the minimum maximum velocity. If that velocity is not achieved, it would be flagged in your results. Rainfall settings, you have the option of a generation method of using the default diagram, or if you're based in South Africa, you could use the South African Weather Service grid, where if your project is georeferenced, it will automatically zoom into the position. Alternatively, you could type in an area and Civil Designer will zoom into that area and gather all the rainfall data needed to calculate your intensity. So let's say we're looking at foreways. The map data was successfully loaded. If we look at that in more detail, we've got everything from a lower 2-year return period to an upper 200-year return period, and then looking at the duration. From that, Civil Designer is able to calculate your rainfall intensity. Moving on to infiltration rates with your antecedent moisture conditions. This is Red Book information that we've included into the module. Inflow hydrographs can be used if you've got on-site information and you'd like to include that in your analysis. You have the option of a reservoir file to model the detention or the retention of these reservoirs. Remember that this information could also be obtained from your surveying terrain functionality. Looking at storm data, we give you numerous storm types to choose from. As an example, with the Chicago storm, if you've got intensity, duration, frequency, curve information, you could populate that. Looking at what the hydrograph looks like for the Chicago storm. You can simulate pumps in your network where you could have up to 4 pumps per pump station. Your depth increments will be used for your quantity purposes. If you want to go and customize this, you can go and select your own increment and then click on Generate Increments. Moving on to bedding classes. SABS bedding classes are built in by default. You can go and customize your bedding classes. Node types can also be created and customized, where you could go and specify the material, your chamber dimensions, what shape you'd like to use, and then browsing through the different node lids. Civil Designer can also automatically size these nodes according to your pipe sizes. Last thing I'd like to point out is the link types, where you could go and specify the different link types. There's numerous options there to be customized. You aren't limited to round pipes. You can go and look at the different shapes. Remember, we still have a CAD drawing in front of us. Now that we've looked at the different options available, we can convert that CAD drawing into our network. We do so by going to File, Import, Convert Drawing Entities, specify which CAD layers represent your stormwater entities. It does the conversion, and then just zooming in, that is what our network looks like at this stage. Using your contours and your slope arrows, you could go and specify your catchment areas by going to Graphical and adding them. Once you're done, you'd run the analysis after you've checked for any error. Done that to save us time, so I'm going to go to File, Project Settings, and then bring in the previous stormwater file that we've had. And then viewing the results, we go to View Results. That would be a summary of our network looking at the runoff flow overflow, volumes, node layout, link layout, and the hydraulic elevation. Civil Designer could also calculate your quantities for you. When doing this, it also includes your excavation volumes with the extra over intermediate and hard material, should you have that. Looking at the bedding and backfill volumes, culvert lengths, and manhole depths. You could also go and view this all in a vertical alignment. If you go to Tools, Vertical Alignment, you could go and browse through the different branches. You're able to go and make changes to your design here. As an example, you could select Interpolate, click on point and an endpoint, and perhaps a good idea to go and switch off that energy grade line for now. You could also go and insert and delete manholes using this vertical alignment. If you've got other services associated to your project, you can go to auxiliary services and check for clashes. When looking at plotting, you could either plot the entire network or you could select portions of the network. In that case, you'd go to graphical, mark everything upstream, select a manhole, everything upstream of that manhole will be highlighted, right click and quit, and then go to plot, generate, select which of Civil Designer's customizable sheet file you'd like to use, the sheet size, and if you'd like the layouts at the bottom over here, that will dynamically update as you make changes to the design or you want separate CAD drawings. Here I'm choosing to plot only what we've graphically marked. If you've got the crossing services and you want to include them in the long sections, you can do so. Specify which scale you'd like to use, and then what you would like plotted. On the right, we have the stormwater schedule with lots of information that could be utilized on site. We've got the plan view that you can customize what you want displayed. Looking at the long section again, you could go and customize what information you want associated with the long section, and you can take your company's title block and incorporate them into these sheet files. Moving on to the sewer module, I'm going to turn off stormwater and then turn on the sewer or the foul water. I'm also going to turn on the earth connections or property connection details. Going to my CAD layers, I'm going to turn off what we had for the stormwater and then zooming in. What we have in front of us is the sewer network. We've got the house connections. We've also got the lowest point within a stand that Civil Designer calculates for us. All of these display settings can be changed according to your standards. I'm not going to export to any other software program. I select sewer mode, go to File, Project Settings, and I'm going to bring in a clear example of the sewer module, and then together we'll build it up so that you can see how it's done. And then go back to my CAD layers. I'm then in this example convert the CAD drawing into our network. If you prefer not to use this functionality, but instead you'd like to do it manually, you can go to the graphical menu and manually draw this in. In our example, we then convert these CAD entities. Before we do so, we go to the Edit menu, we select Default Settings, where you can go and specify your manhole types, manhole conditions. Take note that you can specify drop distance. The material type, which again you could customize, and then looking at the diameter, the option is there to auto size the diameters according to your inflow information. The SABS bedding classes are there. You can go and customize them. And should you want to use the graphical function, Civil Designer will also limit the distance between your manholes. You'll see that there's a lot of similarities between the sewer and the stormwater module, really taking advantage of Civil Designer's common interface. Moving on to the design parameters, there's numerous inflow calculation methods to choose from. You can specify Colebrook-White or Manning friction loss formula. The dynamic inflow update is available for you. In that case, Civil Designer, when it puts in your house connections, will take them into account and calculate the inflow, specifying the minimum maximum velocity. If you choose to use the unit hydrograph parameters, we give you the option to go and customize the land use categories. All according to your red book, you could go and make changes to this. You could go and insert your own categories. If you do make changes to these values, you could revert back to the defaults. Looking at unit flow parameters, if you prefer to use this calculation method or this equation, we'll also give you an attenuation curve, making provision for the peak factors and the population utilizing the network. Got Harmon parameters, if you prefer to use the Harmon formula. As with the stormwater, if you analyze an existing network, you can bring in a hydrograph with the existing site information. Previously mentioned, you can use the land use categories where I pointed out the unit hydrograph. Just taking a look at the unit hydrograph types and browsing through the different options. You are able to simulate pumping within your network. Civil Designer will work out the quantities. You can go and specify the depth increments for these quantities. Should you want to go and change the increment, you could do so. Moving on to bedding classes. As mentioned, the SABS bedding classes are there. You can go and customize your bedding classes. The different node types are available. You can go and create your own node types. You can go and customize how you want this displayed. Civil Designer will also size your nodes according to your pipe sizes. The different link types available to you. You can insert your own custom type. Remember that at this stage, we still got a CAD drawing. Now that we've looked at the different options available to us, we then convert the CAD drawing into our network. We do so by going to File, Import, Convert Drawing Entities, specify which CAD layers are used for the different network entities, and then click on OK. It does the conversion within a couple of seconds. We've got our sewer network. If it's a fairly small network and you want to graphically insert the inflow, you can go to Graphical, Edit Data, click on a manhole, and then insert your inflow information. Alternatively, if you've got a larger network, it would be rather time consuming to do everything manually. So instead, what you'd prefer to use is parcels. Let me show you what parcels is all about. I'm going to go to the survey mode. I go to parcels. I select create from stand numbers. So I'm going to use the CAD entities that we previously created for our stands. I'm going to convert each stand number into a parcel, and from that we are able to calculate our house connections. Click on OK. It goes ahead with the parcels. Going back to the sewer mode or file water mode, we go to connections, connection defaults. Go and specify which defaults to use with the different sewer position options, the unit flow class, and then Civil Designer can also calculate the minimum ground level on your parcels. Going back to connections, looking at the different connection types, anything with a height difference less than 150 mil between the invert level of your main sewer line and the invert level of your house connection will be flagged as not possible. You can go and customize these. Letting Civil Designer automatically insert these house connections, I go to Create Automatically, specify which defaults to use. It goes and creates these house connections. Now in plan, we've got the house connections, but at this stage, we don't quite know if we are able to drain into the main line. We therefore go to Analysis, select Network, specify which parameters to use. If you want to analyze the entire network or portions thereof, it will take connections into account and use them for your inflow. It runs through analysis, which it's done here with the results. But at the same time, it's giving us a warning that there are 5 stands that are not able to drain into the main line. If you would like some additional information as far as that's concerned, you select connections. You can go to type of connection, right click, sort in ascending order. There are the 5 stands, and the reason why they are not able to drain into the main line is because, as mentioned before, there's not sufficient depth difference between the invert level of the main sewer line and the invert level of your house connection. You can either change the depth of those links manually. Alternatively, you could go to connections and ask Civil Designer to update the sewer levels for us, which I've opted to do here. It will then calculate the main line again, ensuring that the stands are able to drain into the main line. There's a summary of our network with the inflow, the flow, overflow, node layout, link layout, hydraulic elevation. Looking at the sewer connections, if I go and right click there, select sort to ascending, there are no longer not possibles, but rather type 1 connections. Remember that Civil Designer will also calculate your quantities for you. It will take the extra over intermediate and hard material into account should you have rock on site. You are able to go and view this all in long section, where you also have the option of changing the design within the vertical alignment. If we go and browse through the different branches, in my display settings, I've turned on the other modules so you can see what it looks like in the long section. On the left-hand side here, we've got the different tools that you can utilize to change manhole positioning. You could ask Civil Designer to calculate elevations between manholes, and it will straighten the grade between them. You also have the option to delete manholes and insert multiple manholes. Remember that with your different services, you can check for clashes, specify which services you want to check. Civil Designer will then show it to you in plan, as well as if you right click in long section, where you could go and move your manholes up and down. You also have the option to write out a CSV file with the clashes information. If you want to go and plot this out, you can plot the entire network or you can select portions thereof. If you go to plot, generate, select which of Civil Designer's customizable sheet file you'd like to use, things like the sheet size. If you want layouts here at the bottom that will dynamically update as you make changes to your designs. Specify if you want to plot all manholes, specific manholes. In that case, if you do go and select a manhole, all the manholes downstream from that manhole will be an option. If you choose to plot crossing pipes, you can do that too. Specify what scale you prefer to use and what you would like plotted. No need to rotate it in this case. Switching on the option to show a sewer schedule. Looking at the right-hand side, zooming into the sewer schedule, you can customize the plan view and then zooming into the long section. Remember that this is all customizable and will be updated as you make changes to your plot. Moving on to the water module, I'm going to my display settings. I'm going to turn off the sewer option and turn on the water display. At the same time, I'm then going to turn off the sewer CAD entities that we used in the previous example. Zooming into our water network, that is what it looks like. How did we get there? You may be asking. You go and select the water module. No need to import or export. And then you could go and graphically draw this in. For demonstration purposes, I'm going to convert a CAD drawing into our water network so that you can see how we get to this stage of the design. I go to File, Project Settings. Let's bring in an empty example. Let's go and turn on the CAD entities that we then convert into our water network. Before we do the conversion, we can go to Settings, Pipe Defaults, go and specify which pipe defaults to use. We've got over 2,212 pipe options. Looking at the node defaults, if we go to Settings, Node Defaults, inside Civil Designer, we've got preset demand patterns to choose from. Should you not choose to use one, you can use the uniform pattern. Browsing through the different options, looking at different demand patterns. The demand through the day would vary depending on the population using the network. Early in the morning, demand at its lowest. As people start waking up, the demand picks up. And throughout the day, it drops and picks up. You can browse through the different demand patterns and utilize them at different points within your network. Having set up those two settings, you can convert this CAD drawing into our water network. We do so by going to File, Import, Convert Drawing Entities, and then specifying which CAD layer you'd like to use for the different water entities. In this example, I'm just going to use the water lines CAD layer, and let Civil Designer populate the rest for me. If I've got additional layers for multiple pipes, I could specify that as well. And I'm presented with this confirmation dialog box. If I'd like to go and insert reservoirs, I go to Graphical, Draw Reservoirs. Select the reservoir, right-click, go to Water Operations, Edit Reservoir Data. Civil Designer uses project information and automatically populates this, but you'd obviously want to go and put in your own project requirements. Selecting connections, you can go and specify which pipes are connected to the inlet and outlet or both. You could specify things like the shape of your reservoir. And if you've got attachments, you can incorporate them into water-specific entities. It could be on-site information, it could be a water report, locality maps, etc. Putting in your pump station, you go to Graphical, Draw Pumps, select where you want the pump to be, select it, right-click, Water Operations, Edit Pump Station Data. Got a whole catalog of pumps. You can go and customize your catalogs. If you go to Select Pumps, specify the required head in your network, as well as the required flow. Click on Search. Civil Designer goes to the pump catalog and gives you the different options available. Once you've selected the most appropriate pump, click on Select. You could, for instance, turn on the controls for your pumps relative to the rest of the network. Alternatively, if you prefer to put in a borehole, you can delete the pump, go back to Graphical, Select Draw Borehole. As before, select borehole, right-click, go to Water Operations, Edit Borehole Data, where again you would go and specify your pump information and the controls. To save us time, I've got a project that already has the correct borehole and reservoir information, so I'm going to bring back that original water file, going back to project settings, bringing back the original file. With the sewer module, we created parcels. We went to the survey mode, we went to parcels, and then we created parcels from stand numbers. We could utilize those parcels within the water network to put in our house connections. We do so by going to Connections, Create Automatically, specify which parameters to use, order of precedence, and then click on Start. It goes and puts connections with the confirmation. If you'd like more information with regards to those connections, you can go to Data, select Connections, and then browse through the different options. Looking at fire hydrants, you can go to Graphical, Draw Hydrants, right-click, Hydrant Defaults. Looking at the different categories, you can go and add your own categories. That circle around the cursor shows the extent that the hydrant covers. In a similar manner, if we go to Graphical, Draw Street Taps, we can again go and right-click, put in Street Tap Defaults. This creates quite a bit of information. If you want to turn that off, you go to your water display settings, looking at the street taps, and then switch off the circle as well as for the hydrants. While I'm here, I'm going to go to my pipe defaults. I'm going to select everything I've got and delete that. And I want to go and customize the pipe display information according to the flow in my network. Q is equal to, right click and select flow. Changing the color scheme, selecting flows, and then changing my increment with the customizable color wrap. Anything with low flows will be blue. Anything with the higher flows will be red. Before we see the changes, we need to analyze. Before I analyze, I want to show you that if we go to Tools, we can go and view the vertical alignment, where Civil Designer will automatically insert your air and scour valves according to your placement parameters. Even though it's inserted the air and scour valves, you can also manually insert and delete the automatic options. I have the option of going to Analysis, checking for any errors. If I've got no errors, I can run a single step analysis where I make provision for minimum, maximum, and average demands. Alternatively, I have the option of a time simulation. Within the time simulation, you can run a simulation for up to 7 days. Civil Designer will also calculate your chlorine concentration within the network at different periods. If I choose to show the reservoir water levels will be displayed throughout the simulation. Click on Start, looking at the water level within the reservoir. If I click on Messages, if I've got errors or warnings, they will be presented here. I can, for example, select a warning, then click on Edit or Show. If, for instance, my reservoir is running dry or there are pipes that are not connected to the main line, it will be pointed out to us. Not forgetting that Civil Designer will calculate your quantities, your bends and junctions, as well as your connection quantities, where it will even calculate the amount of saddles within your network. If you want to view the results, you can go to the Results browser, select the latest time simulation, and as you go and select the different times in the results browser, the Q values and the pipe colors will update every 15 minutes. You also have the option of plotting the entire network or selecting portions thereof. In order to plot it, we go to Plot Generate. Select which of Civil Designer's customizable sheet file you'd like to use, the sheet size. You can specify a stop and start chainage if you choose not to plot the entire section. Specify the scale to be plotted as well as the region. I'm opting for a water schedule. Looking on the top right-hand side, we have the water schedule. We have the plan region as well as the long section that is completely customizable. There you have it, everyone. Thank you very much for joining us. I hope you enjoyed it as much as what we did putting it together for you. Please let us know if you've got any additional questions. Also, please do visit our website, FAQ page, should you require any other functionality explanations. Goodbye for now.